Guys, yesterday we started with the model number two, that is a static and dynamic force analysis, right? So I will just revise what we have seen in the last lecture. Okay, so we started with the inertia force. We understand the concept of inertia force. We understand the concept of inertia torque, right? So inertia force is equal and opposite to the accelerating force. Okay, so basically, how does the inertia force arises? That is due to the mass of the rotating or the reciprocating parts of the machine. Okay, so that we have understand. Then I have explained you the D'Alembert's principle. So how we write the statement: summation of inertia forces plus external forces equal to the zero. So that is nothing but a D'Alembert's principle. Then we understand the difference between the static force analysis. What is exactly a static force analysis? Okay, as I said in the last lecture. Then what is dynamic force analysis, right? Then I have given you one example of static as well as the dynamic force analysis, right? Uh, so basically, I stated yesterday that in this module we will study the inertia forces and the effects on the IC engine mechanism. So as a case study, we are taking IC engine mechanism. Okay. So then we went to the derivation of some basic formulas. So we started with the dynamic analysis of a we started with the dynamic analysis of a slider crank mechanism, right? So basically, we have taken a case study as a IC engine. So in IC engine, the mechanism which is used or designed for IC engine is nothing but a slider crank mechanism, right? So that slider crank mechanism we have used. Okay, then we have understand what is OC, what is PC, right? Uh, then OC is the crank, PC is the connecting rod. So everything we have understand. Okay, yesterday, and then L is the length of the connecting rod. R is the radius of crank. Okay, so crank is rotating. IDC is nothing but inner dead center, outer dead center, right? What is phi? What is theta? Okay, so that we have understand. You can watch the video if you have missed the lecture. Okay. Then we derive the velocity of a piston, that is a linear velocity of a piston along the stroke line PO. Okay. Then we derived the formula for the acceleration of a piston, right? Uh, then angular velocity of a connecting rod omega PC and angular acceleration of a connecting rod. Okay. Now today we will understand. Yesterday I have given you some introduction of the forces acting on the reciprocating parts of the unit. Now we have done the dynamic analysis of a slider crank mechanism. So now we will be considering the slider crank mechanism only. First of all, you try to understand. We will be considering slider crank mechanism only, but now here we will understand what are the forces acting, and we have to calculate. We have to basically we have to design. Na? So we are doing an analysis, force analysis. Okay. So the various forces acting on the reciprocating parts of a horizontal engine. Okay. So basically, this is the you can say the force diagram of a. This is a force. You can say FBD, or you can say the force. We have to draw the FBD of that slider crank mechanism. Okay. So this is nothing but a cylinder. Let us say this is nothing but a cylinder, and here we will have a piston, let us say. Okay, so then this is nothing but a connecting rod, this is nothing but a crank, this is nothing but a stroke line. Okay, right? And so these are the components like piston, cylinder, crank, connecting rod. Okay, then this indicates the crank. Okay, this indicates the stroke line, right? Then we'll have an inner dead center, outer dead center, right? So these are the components already, guys, we have understand. So let us name it and start with the analysis. Okay, so let me call this as a point P, and let me call this as a point O. So what is PO? This PO is nothing but a stroke line along which the linear velocity Vp is acting. Okay, and let me call this as a point C. So what is OC? OC is nothing but a crank, right? And PC is nothing but a connecting rod. Okay, so we have considered. Now let us say this angle of inclination is phi and this angle of inclination is theta. Okay, so this we have considered. Now, first of all, to understand what are the forces acting, so let us say that this force is nothing but a Fp. So what is Fp? Fp is nothing but a net force acting on the piston. Fp is nothing but what? Net force acting on the piston. Fp is equal to net force acting. Okay. So now I am doing the force analysis. So the first step is draw the FBD or a force diagram. Okay. So net force acting on the piston. Okay. So first of all, I have to calculate this FP. What is FP? Net force acting on the piston along stroke line. along the stroke line PO. Okay, along the stroke line PO, right? Next, I am considering as a FN. Okay, so let me derive this later on. First of all, we'll understand how to draw this force diagram. Then this is nothing but the FP. Okay, so let us say FP is nothing but a. So I am showing FP here also. FP. So this FP is nothing but acting along the straight stroke line. Okay. Next, let us say Fn. Okay, and let us say this is nothing but the WR. Okay, so what is WR? What is WR? WR is nothing but the weight of the reciprocating parts. Weight of the reciprocating parts, right? And then uh, let us say Fn. Okay, and let us say this force is nothing but the Fq. Okay, now first of all, let us understand what is this Fn and what is this Fq. Okay, so what is Fq? Okay, FQ is nothing but the force acting along the connecting rod. What is FQ? FQ is nothing but a force acting along the connecting rod. Acting along the connecting rod, right? This way of understand. And then Fn. What is Fn? Fn is nothing but the a normal reaction. You can call Fn as a normal reaction. And to be more precise, Fn is nothing but a normal reaction or thrust acting on the sides, acting on the sides of the cylinder wall, right? Acting on the sides of the cylinder wall, because basically this is nothing but a cylinder and a piston arrangement, right? So there is a cylinder inside the IC engine, and inside the cylinder we have a piston, and then we have a. You will understand this more components detail in the IC engine. Okay, here we have. I am explaining the force analysis. So what is Fn? Thrust on the sides of the cylinder wall. Fp is nothing but a net force acting on the piston along the stroke line PO. Fq is nothing but a force acting along the CR. Okay, and WR is nothing but a weight of the RP, reciprocating force. So I hope you have understand this one. This is not the end of the force diagram. So we will. So now this point you have understand. So now we will elaborate it. Okay. So what I said, this is FP. Okay. So now I have known this is Fn. This is nothing but WR. Okay, this is nothing but a WR, and this I said it is FQ. Okay, this I said it is a point C. I said this is a point O, and this is a point U. Okay, now basically this FQ. What is this FQ? FQ is nothing but a force acting on the connecting rod. Now this FQ can be resolved into the two components. See, this FQ is nothing but a force acting on the component rod. It can be resolved into the two components. How many components are there? There are two components where the FQ can be resolved. Okay, so what are the two components that we have to understand here? Okay, so oh sorry, FP. Okay, FP. Then this is WR, Fn, C, O, and this is nothing but the P. Right. So now what I was saying, FQ is to be resolved as a two component. So let me resolve that as a two component. So how will you resolve this? Okay, so there are two components. Let us say this is the first component. Okay, let us say this is the first component. Okay, and this is the second component, right? So this first component is called as a FT, and the second component is called as a FB. Okay, clear? So this I have resolved into the, so this is nothing but the 90 degrees, right? So this FQ I have resolved into the two components. One is the FT and second one is the FB. Now let us understand what are these two components. It is very, very important to understand. Okay, so FT is nothing but, FT is always perpendicular to the crank. So FT is nothing but a perpendicular to the crank OC. What is crank OC? So what is this FT? FT is nothing but the tangential force acting at the crank pin. FT is nothing but the tangential force. What is this FT? Is a tangential force. आता ह्या FT मुळे काय होणार आहे ते पण मी तुम्हाला सांगतो. Okay, so FT is nothing but a tangential force which is acting at the crank pin. At the crank pin means what? This here. This OC is the crank, na? So at the crank, wherever there is a location of the crank, at the crank you will have a crank pin also. So normally the connection is like connecting rod, crank pin, and the crank. Okay, so this is how we call it. So that detail working you will understand is IC. Okay, but now here you understand that FT is nothing but the of tangential force which is perpendicular to the crank OC, or it is perpendicular to the crank OC, or it is nothing but the tangential force which is acting at a crank pin. It is nothing but a tangential force acting at a crank pin. Now, what happens? Basically, what happens because of this because of this Ft? Okay, let us understand this. Okay, now this Ft basically produces a crank pin effort. This Ft produces produces a crank pin effort. It produces a crank pin effort. Crank pin effort means what? It produces a torque. It produces a torque on the crankshaft. It produces a torque on the crankshaft, right? And that we have to calculate. Have you understand, guys? So I am trying to explain the force analysis. See, there are a number of forces acting on the IC engine. As an analytic engineer, analysis engineer, you have to understand it. So as I said that FP is nothing but a net force acting along the stroke line. Fn is nothing but a side thrust. WR is nothing but a weight of the reciprocating parts. Then FQ is nothing but a force which is acting along the connecting rod. This FQ again is resolved into the two forces. One is the Ft. Ft is nothing but a tangential force or a force perpendicular to this crank OC. Force perpendicular to this crank OC. And this, because of this Ft, it produces a torque on the crankshaft, or it is also called as it also produces a crank pin effort. Is it clear? And next forces. Now I will talk about the FB. Now what is FB? Let me rub this first of all. Now can anybody tell me what is this FB? Now where is FB acting? Now FB is acting along the crank. It is FB is acting along the crank. You can see this is the FB, na? So it is acting along the crank OC. FT is acting perpendicular to the OC. This is very, very important. And FB is acting along the crank OC. Okay. So this FB is also called as a radial force. What is this FB called as? This FB is called as a radial force. It is not a tangential force, but it is a radial force acting on the crankshaft. It is radial force acting on the crankshaft. Crankshaft is basically a rotating element which is connected to the connecting rod. See, piston is connected to the, basically how is the connection? You understand, piston is connected to the piston pin. Piston is connected to the piston pin, right? Then this piston pin is again connected to the connecting rod. That is a small end of the connecting rod. There is a small end of this is connecting rod is like this. Okay, this is a small end and this is a big end. To the big end we have a crank pin. Okay, and with the help of this crank pin and crank, it is connected to the crankshaft. Okay, so basically crankshaft is a rotating element. Okay, and this crankshaft is then connected to the flywheel of an automobile, and then gearbox, and this connection goes like this. Okay, so we have to understand the force analysis here. So basically this FB is a radial force which is acting on this crankshaft, and Ft is nothing but a tangential force which is acting on the crankshaft, and it creates a crank effort, right? So I hope you have understand all this, right? So basically now, as I earlier said that, I will rub this all. Now this Ft, what does this Ft do? Ft produces crank pin effort, right? This Ft produces a crank pin effort, and this Fb produces a side thrust, or you can call it as a thrust. Thrust is nothing but a one type of force. So this Fb produces a thrust on the crankshaft bearings. Now you know that a crankshaft is a rotating element, so obviously it is connected with the help of the bearing. So Fb produces a thrust on the, where it produces thrust on the crankshaft bearing. Okay, and Ft produces crank effort, or you can call it as a torque. Okay, now tell me guys, have you understand the force analysis? So finally, now this crank effort, if you want to calculate this crank effort, let us say that is denoted by the T. So this crank effort T, this T is nothing but the crank pin effort or the torque which is produced by the Ft, that is a tangential force, and this is nothing but the Ft multiplied by R. And what is Ft? Tangential force. And what is R? R is nothing but the crank pin radius. It is nothing but the crank pin radius. So R is nothing but the crank pin radius. Is it clear, guys? Now please tell me, have you understand all the forces what I have explained? Now I will complete this diagram. Have you understand all the forces? So I can complete the diagram. Yes? Anybody? Message please. Have you understand all the forces? Okay, so I will start to complete this now. So FP, Fn, anybody, what is FP, what is Fn, what is WR? Okay, let us say this is phi, let us say this is theta, O, P, C. Okay, here you will have a FQ, right? And then let me change the color pen. So take green. So now this FQ is resolved into the two components, right? One is the FB and one is the FT. Okay, what is this FT? Tangential force. What is this FB? Radial force acting on the crankshaft. Okay, this FB produces the thrust on the crankshaft bearing. FT produces the crank pin effort or the torque, which is equal to FT into R. Okay, so now if I, let us say, if I produce this, line, if I produce this line, it goes like this. If I produce this line, it will go like this, right? So this is nothing but the FQ. This is the extension of the force FQ, and then what is this? So this is nothing but the FB, right? So this is nothing but the FB. Okay. So this is FQ, this is FT. If this is FB, this is also FB, right? Now let us understand the angle. Now if this total angle is 90 degree, okay, this total angle is 90 degree, okay, then this angle will be theta plus phi. This angle will be theta plus phi, okay, and then what will be this angle? This angle will be 90 minus theta plus phi. Okay, is it clear? Okay, is it clear or not? And if I produce again this line, if I get this line, if I produce this line like this downward, okay, so this will indicate, this indicates again a FT. So this is a line also FT, this is also FT. Okay, so this is FB and this is FB. Okay, so this is called as a force analysis diagram. Okay, now I will show you the final diagram here. Okay, so this is the final diagram. Okay. Now see again FP, Fn, WR. Okay, so this is again FP. I am showing FQ. FQ is converted into the FT, right? Try to understand this. Then this will be FB obviously. Okay, and then let us say this is 90 minus theta plus phi, because this total is 90. This angle is theta plus phi. Okay, and if I draw a line, this is not necessary, but if I draw a line O to N. That is, if I draw a perpendicular line O to N, then I will get two more angles. That is 90 minus phi and 90 minus theta. But these are not required. This just I have shown here. Now, guys, tell me, have you understand this or not? So I will move on to the calculation. Yes, have you understand the force analysis diagram? Please message yes or no. All the forces and how to draw the diagram. Anybody? Hello. Okay. Now what is your aim? Now what is your aim? You have to derive. So first of all, piston effort. Now what is the piston effort? It is nothing but a net force acting on the piston or crosshead pin along the line of stroke. So piston effort is nothing but the net force which is acting along the line of stroke PO. Okay. So you have to calculate this. So first of all, let's say that small nr is the mass of the reciprocating parts. Reciprocating parts means what? Example, piston, crosshead pin or gudgeon pin. This piston pin is also called as a gudgeon pin because basically, as I said, that you will understand in the IC engine, piston is connected to the piston pin. Okay, so piston and piston pin are inserted inside the engine cylinder. Okay, and this piston pin is connected to the crank connecting rod. Small end is there, and then there is a big end is there. Okay, and then this small end and big end, then it is connected to the crank and the crankshaft. Right, as I said that. Okay. So even if you Google on a YouTube, you will get to know the components. If you don't know how the component looks, okay, you will get to know that. So in kg, let's say WR is the weight of the reciprocating part. Okay. Now acceleration of the reciprocating part. Now already we have derived this. What is that formula? The acceleration of a reciprocating R. This we have derived in the last lecture. So AR is nothing but the AP is equal to omega square R cos theta plus cos 2 theta upon N. So this is the basic formula which we have got from the dynamic analysis of the cyber mechanism. Okay. Now, inertia force or now you know that what is inertia force? The force is which is acting equal and opposite to the accelerating force. Okay. Now this inertia force or accelerating force of the reciprocating part is given by what? Inertia force Fi. We know that F is equal to m into n. That we have already understand. So inertia force is nothing but F is equal to, let us say Fi is the inertia force, M1 is the masses of reciprocating part, and AR is nothing but the acceleration of the reciprocating part. So if you know MR, if you know AR, what we will get? We will get the inertia force. Now this inertia force and exciting force are equal but opposite. Okay, we know that inertia force Fi is equal to minus of exciting force. So that we have understand. But their magnitude is same. That is a MA. Only the direction is same. If inertia force is acting like this, exciting force will act like this. Okay, if accelerating force is acting like this, inertia force, sorry, exciting force will act like this. But the magnitude is equal. That is M into A. Okay, so that you understand first of all. So I am getting Fi is equal to what? I am getting Fi is equal to MR, because we know AR is nothing but the omega into cos theta plus 2 cos theta. So I am getting this MR omega square R cos theta plus cos 2 theta upon N. Okay, so this is nothing but the, so you have to remember this formula AR. So multiply M into AR, you will get a formula. So the first step is to calculate the inertia force acting on the piston, that is a reciprocating part. Is it okay? So now if you understand this, now basically, first of all, let us say that now basically we have two engines. One is a horizontal engine and second is a second is which? Vertical engine. Okay. So if the engine is placed horizontally, horizontal engine means what? This is the horizon. This is a piston, and let us say this is a connecting rod. Let us say this is the horizontal engine position, and what is the vertical? This position. Okay. This is a piston, and let us say this is a connecting rod. This is a piston, and this is a connecting rod. And here let us say you will have a crankshaft. Here let us say you will have a crankshaft. So this is nothing but a crankshaft. Okay. So either horizontal position or either vertical position. Okay. It doesn't matter. We can do the analysis. Clear? So basically, first you have to understand that this diagram I have already explained. Slider. This is nothing but a slider crank mechanism. SCM. Slider crank mechanism. Right. So basically, this is nothing. Now as I earlier said that theta is equal to 0 at IDC. Theta is equal to 180 degree at ODC, that is outer dead center. So this you know. Okay. Now basically you understand that there are cycles in the IC engine. Okay. So it may be noted that in a horizontal engine, the reciprocating parts are accelerated from the rest. That during the latter half of the stroke. So what I mean to say is that there are two conditions. Which are the two conditions? One is the acceleration. Means what? Let us say you are accelerating. तुमची गाडी आहे. Let us say तुम्ही गाडी accelerate केलं. How will you accelerate your vehicle? By pressing the accelerator pedal. Means what? Acceleration is nothing but a meter per second. Let us say you are accelerating your vehicle. Means what? You are increasing. Second case is what? You are de-accelerating. Means what? You are decreasing the speed. Means what? You are de-accelerating. So that is called as a retardation. That is called as a retardation. Retardation means what? It is nothing but a de-acceleration, right? So acceleration and retardation. There are two phases. So in the IC engine component, the components will either accelerate or component will either retard. Means what? The speed will increase or decrease. So exactly how it happens in which cycle, that you have to understand as an engineer. So it means in horizontal engine, first of all I am talking about a horizontal engine only. Vertical engine I will explain you later on. So reciprocating parts are accelerated from the rest during the latter half of the stroke. Latter half of the stroke means what? When the piston moves from the inner dead center to the outer dead center. Means what? When the piston is moving from IDC to ODC, the reciprocating parts are what? Accelerated. You have to remember this. When are the reciprocating parts accelerated? The accelerate होणार when they are moving from inner dead to the outer dead center. You remember this. And when it is retarded during the latter half of the stroke, when the piston moves from outer dead center to the inner dead center. I hope you are understanding what I am saying this. Okay, basically this is not a word latter, this is a first half. Try to understand, it is the first half. Okay, so you, otherwise you will get confused. Okay, so is it clear? Is it clear to this thing? Okay, this is not the latter, basically this is the first half. Means what? During the first half of the stroke, first half of the stroke म्हणजे लक्षात कसं ठेवायचं? First of the stroke, piston moves from IDC to ODC. That is, the piston moves from inner dead center to ODC. Okay, and Then it is retarded during the latter half of the stroke. Means what? When the piston moves from ODC to IDC, means इथून असा येणार आहे. Okay. Now you might get a question, sir, why are you telling this? Because it has effect on the net load acting on the piston. This has an effect on net load acting on the piston. What is that effect? See, so this effect is like, first up, the inertia force due to the acceleration of the reciprocating part opposes the forces on the piston due to the differences of a pressure in the cylinder on the two sides of the piston. Now, difference of a pressure in the cylinder on the two sides of the piston. This I will explain you in the next slide. I will draw the diagram. Means what? Differences of pressure in the cylinder on the two sides of the piston. म्हणजे पिस्टन असेल तर पिस्टनच्या एका साइडला P1 ऍक्ट होतोय आणि दुसऱ्या साइडला P2 ऍक्ट होतोय. What is this P1? This P1 is nothing but a gas pressure. P1 is nothing but a gas pressure. P2 is nothing but a gas pressure at the another end. सी बेसिकली तुमचं जे पिस्टन असतं ना त्याच्यामध्ये काय होतं, जेव्हा तुम्ही गाडी फर्स्ट स्ट्रोक पडतो तुमचा पहिला स्ट्रोक कुठला असतो तुमचा सक्शन स्ट्रोक, सेकंड स्ट्रोक इज नथिंग बट अ कॉम्प्रेशन स्ट्रोक, power stroke, and third stroke is nothing but the exhaust stroke. I have already explained you in the first lecture. So at the suction what happens, your inlet valve opens. तुमच्या इंजिन मध्ये एक इनलेट वॉल्व असतो. तो इनलेट वॉल्व ओपन झाला की एअर फिल्म मिक्सचर तुमच्या इंजिनच्या आतमध्ये येतं. मग एअर फिल्म मिक्सचर आतमध्ये आलं की ते कॉम्प्रेस होतं. ओके, मग कॉम्प्रेस झाल्यानंतर तिथे एक प्रेशर तयार होतं. सो दॅट प्रेशर इज ऑफ व्हॉट, दॅट एअर फिल्म मिक्सचर. नाउ दॅट एअर फिल्म मिक्सचर बिकम्स अ गॅशियस, राइट, and that is why that is called as a gas pressure which is acting on the two sides of the piston. And normally in the IC engine we use a double acting piston. आपण काय वापरतो, we use a double acting piston. So त्याला आपण म्हणतो double acting reciprocating steam engine. Means what, the flow pressure is acting on both sides of the piston, right, that is P1 and P2. We call it as a double acting reciprocating steam engine or double acting piston, you can call it as a, okay. So basically now what I want to understand that during this phase, which phase, during the first half of the stroke, during the first half of the stroke, first half of the stroke means what, that is when piston moves from the inner dead center to the outer dead center, that is the inertia force due to the acceleration of the reciprocator opposes the force on the piston, opposes on the force on the piston, okay. And on the other hand, the inertia force due to the retardation of the reciprocating parts helps the force on the piston, helps the force on the piston. Means what, सांगायचा मुद्दा असा आहे, if the FP is the net force, let us say FP is the net force or the piston effort, then this FP is equal to FL, okay, FL plus minus FI, plus minus FI. FL is nothing but the FL plus minus FI, okay. Now what is this FL? FL is nothing but the gas net, you can call it as a net gas pressure, net gas pressure, net gas pressure or gas load. मी तुम्हाला नेक्स्ट स्लाइडला दाखवतो. नेट गॅस प्रेशर और गॅस लोड ऍक्टिंग ऑन द पिस्टन, ओके. सो आता जेव्हा तुमची ऍक्सेलरेशन फेज असते, the inertia force due to the acceleration of a receding rod, what will happen, they will oppose the force on the piston. Means what, मला सांगा मग इथे प्लस साइन येईल की मायनस साइन येईल. म्हणजे सांगायचा मुद्दा असा आहे, तुम्हाला समजत नसेल तर मी अजून सोपं करून सांगतो. तर FP, that is a total piston effort, is always equal to FL plus minus FI. What is this FP? Piston effort. What is this FL? Net load on the piston. कुठला net load? Net gas pressure, or you can say the load which is acting on the piston due to the net gas pressure. म्हणजे दोन्ही साइडला पिस्टनचा जो गॅस प्रेशर आहे ना P1 आणि P2, त्याच्या डिफरन्स मुळे जो काय तयार झालाय तो लोड, त्याला आपण म्हणतो नेट लोड ऍक्टिंग ऑन द पिस्टन ड्यू टू द नेट गॅस प्रेशर. आता मला सांगा या FL मध्ये प्लस FI कधी होईल आणि मायनस FI कधी होईल? That is I am explaining over here. Means what? Your FL will become plus FI during the acceleration, during the retardation phase, and your FL will become minus FI during the acceleration phase. म्हणजेच काय, acceleration phase ला when the reciprocating when the masses, reciprocating masses are accelerating, this FI means what, inertia force will oppose this FL. Clear? And during the retardation phase, this FI will help this FL. Means what, it will become plus. आता मला सांगा, तुम्हाला हे लक्षात आलं का, दोन्ही फेजेस, एक्साइटिंग फेजेस आणि रिटार्डिंग फेजेस, आणि त्याचा फॉर्म्युलावरती काय इफेक्ट होते. प्लीज मेसेज मी, हॅव यू अंडरस्टँड ऑर नॉट, अदरवाइज आय विल एक्सप्लेन यू लेटर ऑन. Have you understand? Yes? Yes or no? Okay. I will explain you the diagram also की हा FL म्हणजे काय. So basically now here, what is FL? What is FP? FP is nothing but the net load on the piston minus plus inertia force. Okay, and basically this is nothing but FL. Now what is FL? FL is nothing but a net gas force acting on the piston. आता मी तुम्हाला काय सांगतोय? When the masses are accelerating, when the masses are accelerating, FL will be plus Fi. Sorry, FL will be minus Fi because this Fi is opposing this FL. FL म्हणजे काय मी तुम्हाला पुढे सांगतोय नंतर, ठीक आहे. आणि during retardation phase this FL will be plus Fi because this inertia force. आता हा inertia force कसा तयार झालाय? Inertia force is nothing but a mr into air. हा कोणामुळे तयार झालाय? Because of this exciting masses only, right? So this inertia force will oppose this FL and will help this FL during the first half and the second half. Guys, it is clear or not? Now, first of all, let me help you to understand is what is FL. FL is nothing but a net gas force acting on the piston. Now, basically, let us say this is your piston. Sorry, this is your cylinder. Okay. Inside the cylinder, let us say you have this piston. Okay, so let us say this is nothing but a piston. Okay, let us say this D is the diameter of the piston. D is the diameter of the piston. Now this is nothing but the area of the piston. Okay, so this is nothing but a P1. This is nothing but a P1, and this is nothing but the P2, and this is nothing but the P2. Right. So what is this P1? What is this P1? This P1 is nothing but the gas pressure. What is this P1? P1 is nothing but the gas pressure. कारण आतमध्ये जसं मी सांगितलं गॅस प्रेशर तयार होणार आहे ना एअर फिल्म मिक्सरच्या कॉम्प्रेशनमुळे. एअर फिल्म मिक्सर जेव्हा कॉम्प्रेस होणार आहे ते गॅस तयार होणार आहे. सो P1 इज नथिंग बट अ गॅस प्रेशर ऍक्टिंग ऑन कव्हर साइड ऑफ द पिस्टन. ऍक्टिंग ऑन कव्हर साइड किंवा तुम्ही त्याला काय म्हणू शकता ऍक्टिंग ऑन कव्हर साइड. ऍक्टिंग ऑन म्हणजे ही तुमची जी साइड आहे त्याला बॅक साइड आपण म्हणू शकतो, बॅक एंड साइड. ओके, किंवा तुम्ही त्याला म्हणू शकता कव्हर एंड, कव्हर साइड. मतलब बैक एंड साइड और कवर साइड म्हणतो आपण त्याला. and P2 is nothing but the pressure, gas pressure acting on the piston on the crank end side. crank end side म्हणजे कुठली? ज्या साइडला तुमचा क्रँकशाफ्ट कनेक्टेड असेल किंवा कनेक्टिंग रॉड वगैरे असेल तुमचं, बरोबर ना. मग थोडक्यात ही तुमची वरची बाजू झाली. वर्टिकल सिलेंडर असेल तर ही तुमची वरची बाजू झाली आणि तुमची खालची बाजू झाली. जो हॉरिझॉन्टल सिलेंडर असेल तर हा तुमची बॅक एंड साइड झाली आणि तुमची क्रँक एंड साइड झाली. ओके, तर दोन्ही साइडला काय होतं तर प्रेशर ऍक्ट होतं. ह्या साइडचा P1 आणि दिस P1 आणि P2 आर नॉट इक्वल. त्या दोघांमध्ये काहीतरी डिफरन्सेस तयार होणार आहेत आणि त्या डिफरन्सेसमुळे एक लोड तयार होणार आहे, त्याला आपण म्हणतो नेट लोड ऑन द पिस्टन. आणि ह्या नेट लोडला हा इनर्शिया फोर्स एक तर अपोज करतो किंवा असिस्ट करतो. अपोज कधी करतो? ड्युरिंग द एक्सेलरेशन फेज, and when it will assist during the retardation phase. Now tell me, have you understand this or not? Okay, so if you want to calculate this, if you want to calculate this FP, sorry, if you want to calculate this FL, okay, this FL is equal to pressure into area. So this FL is equal to pressure into area. So the P is nothing but the pressure. What is this P? Pressure. And what is the area? Area, cylinder is of a circular cross section, na? So area will be pi by 4 into d square. Okay, and this P is nothing but a net gas pressure acting on the piston. Now guys, can you tell me how will you calculate this P? What is this net gas pressure acting on the P? Net gas pressure acting on the piston. तो तुम्ही कसं कॅल्क्युलेट करणार? P FL म्हणजे काय? Net gas force acting on the piston. What is that? Pressure into area. What is this pressure? P. Area is what? Pi by 4 into d square. Now what is this P? Net gas pressure acting on the piston. Now at the back end side we have P1. At the crank end side we have a P2. So what will be the net pressure acting on the piston? Okay, this P will be equal to P1 minus P2. This P is equal to P1 minus P2, right? And if we consider the area, now let me elaborate this. This P is nothing but the net gas pressure acting on the piston, which is equal to P1 minus P2 P1 is the pressure acting on the cover side, P2 is the pressure acting on the crank side. Now this you can elaborate like this. You can write it as a P1 A1 minus P2 into A2. Now P1 A1 is what? A1 is what? Cross sectional area on the cover end side, and A2 is nothing but the cross sectional area on the crank side. So you can write like this P1 A1 minus P2 A2. Okay, and this you can write like this P1 A1 minus P2 into A1 minus A. Means what? A2 is always equal to A1 minus A, and what is this A now? This A is nothing but the cross sectional area of a piston rod. Cross sectional area of a piston rod, right? So आयसी इंजिन मध्ये जे काही तुम्ही वर्किंग शिकणार आहे त्याचं फोर्स एनालिसिस मी तुम्हाला इथे सांगतो. इज इट क्लियर? दिस इज हाउ वी कॅल्क्युलेट दिस P, and from this P you will get this net gas force acting on the piston, and from this net gas force, if you plus or minus this inertia force, you will get what? FP. And what is FP? Piston effort. म्हणजे जर तुम्हाला पिस्टन एफर्ट काढायचा असेल तर तुम्हाला किती गोष्टी काढायला लागतात बघा. नाउ गाइस टेल मी, हैव यू अंडरस्टँड दिस और नॉट? Have you understand this or not? Analysis. Please message me yes or no. What I have explained you. Hello. Okay. Chalo. So now FP is what? FL minus plus FI, neglecting friction. Now there is one more concept called the friction. So obviously there is a metal to metal contact piston and cylinder. So obviously that means the friction. The friction between the contact point between the piston and the cylinder. Cylinder and piston याच्यामधलं friction. Okay. So तो जो neglect केला. FL minus plus FI. If you consider the frictional force will always oppose this net gas force acting on the piston. So that will be FL minus plus FI minus RL. So this is the formula to calculate the net piston effort on a horizontal engine. Okay, not for a vertical engine. What is FL? This is FL. FL is nothing but the net gas force acting on the piston. Net gas force म्हणजे काय? P multiplied by area. What is area? Pi by 4 d square. What is P? Net gas pressure. Now what is this P? P is nothing but a P1 minus P2. So this is how we calculate this. Okay. So I hope you understand this. Okay. Now negative sign is used when the piston is accelerated. Now this I have already told. See, during the acceleration phase, this Fi will oppose the FL. So use a negative sign. During the retardation, FL will assist this Fi. So use a positive sign. Okay. So these I have already explained. Next. Then how to calculate this FL? FL is nothing but the P1 A1 minus P2 A2. Okay, because basically what is FL? What is FL? P into area, na? And what is P? Net gas pressure acting on the piston. So P is equal to P1 A1 minus P2 into A2. So this same. So P2 into A2 can be written as P2 into A1 minus A. Okay. So here. What is A? A is nothing but a cross section area of the piston rod. What is P1? Pressure on the back end side of the piston. P2 is pressure on the cranking side of the piston, as I showed in the diagram. And A1 is nothing but a cross section area on the back end side and the crank end side. Okay. So I hope you have understand this. And next, net load on the piston FL we can calculate. So you have two formulas. You can either calculate FL like this. FL is equal to P1 A1 minus P2 A2. You can calculate like this also, and then you can calculate by using this formula, that is FL is equal to pressure into area. So at the time of solving a problem, we'll understand how we are modifying this problem. Okay. So FL is nothing but a net load on the piston, or you can call it the net gas pressure. Net load means what? Net gas force, or you can call it a net gas force acting on the piston. लक्षात घ्या, हा लोड म्हणजे कुठला आहे? गॅस फोर्सचा आहे किंवा गॅसच्या प्रेशरच्या डिफरन्सचा लोड आहे. हे लक्षात घ्या पहिल्यांदा, हे महत्त्वाचं आहे. ओके. अँड डी इज द डायमीटर ऑफ द पिस्टन, आणि हा पी म्हणजे काय? गॅस प्रेशर ऑफ स्टीम और गॅस ऑन द पिस्टन, म्हणजे नेट गॅस प्रेशर म्हणतो आपण त्याला. ओके. इज इट क्लियर? टेल मी, हॅव यू अंडरस्टँड दिस और नॉट? सो फायनली आय हॅव कॅल्क्युलेटेड FP. So for horizontal engine, FP is equal to FL plus minus FI. So this is the formula what you have to understand. Okay. Now in case of the vertical engine, so let us say engine is vertical. Vertical means what? Let us say this is the position. Okay. So this is the piston. This is the connecting rod. Let us say this is the connecting rod and this is the crankshaft. Okay. So let us say this is the connecting rod. Okay. This is the piston. This is the piston, right? So This is called as a TDC, and this is nothing but a PDC. TDC means what? Top dead center. PDC means what? Bottom dead center. Means what? When your piston is at this position, म्हणजे पिस्टन तुमचं जे वरती मूव्ह होईल, सगळ्यात टॉपला मूव्ह होईल त्याला आपण म्हणतो टॉप डेड सेंटर, आणि जेव्हा पिस्टन जेव्हा तुमचं बॉटमला मूव्ह होईल डाऊनला, त्याला आपण म्हणतो बॉटम डेड सेंटर. हॅव यू अंडरस्टँड टॉप डेड सेंटर अँड बॉटम डेड सेंटर? Okay, so moving a piston at the top end, top dead center, at the down, topmost position, top dead center, bottom most position म्हणजे bottom center, bottom dead center. Okay, तर हे झालं वर्टिकल इंजिन. ओके, मग वर्टिकल इंजिन म्हणजे काय? तुमची ही अशी मग हॉरिझॉन्टल इंजिन होतं. आता ह्या वर्टिकल इंजिन मध्ये काय होतं? इन केस ऑफ द वर्टिकल इंजिन, weight of the reciprocating parts assist the piston effort during the downward stroke. डाउनवर्ड स्ट्रोक म्हणजे काय पाहिजे समजून घ्या. डाउनवर्ड स्ट्रोक. ओके, so downward stroke is means what? When the piston moves from TDC to BDC. कळलं? पिस्टन कुठे मूव्ह होणार आहे? TDC to BDC. So when the piston moves from TDC to BDC, स्ट्रोक तुमचा डाउनवर्ड आहे. ओके, आणि तुमचे जे वेट ऑफ द रिसिप्रोकेटिंग पार्ट्स आहेत ते कसे ऍक्ट होत आहेत? WR. हा पण डाउनवर्ड आहे. म्हणजे काय होईल? प्लस होईल की मायनस होईल? तुमचं प्लस होईल की मायनस होईल त्या केसमध्ये? हा तुमचा जो वेट आहे WR हा डाउनवर्ड ऍक्ट होतोय, आणि डाउनवर्ड जेव्हा स्ट्रोक असेल वर्टिकल इंजिन मध्ये, डाउनवर्ड स्ट्रोक म्हणजे काय? पिस्टन इज मुव्हिंग फ्रॉम TDC टू BDC, म्हणजे ह्याचा फोर्स कुठे ऍक्ट झाला? डाउनवर्ड झालं ना. म्हणजे FL जो असेल तो डाउनवर्ड झाला, म्हणजे FL प्लस WR होणार. क्लिअर? सगळ्यांना क्लिअर झालं का? आणि जेव्हा अपवर्ड स्ट्रोक असेल, अपवर्ड स्ट्रोक असेल तर पिस्टन कुठे मूव्ह होतो? BDC टू TDC. ओके, म्हणजे अपवर्ड स्ट्रोक म्हणजे हा झाला, आणि WR कुठे ऍक्ट होणार आहे? डाउनवर्ड. WR म्हणजे काय? वेट ऑफ द रेसिस्टिंग पार्ट, म्हणजे दिस विल बिकम मायनस. ओके, क्लिअर? सो फायनली पिस्टन एफर्ट काय असणार तुमचं? FP इज इक्वल टू FL मायनस प्लस FI प्लस मायनस WR मायनस FL. दिस इज फॉर अ वर्टिकल इंजिन. Okay, so in vertical engine there will be plus minus WR, and in horizontal engine we will have only formula FP is equal to FL minus plus FI minus RF. Okay, because in horizontal engine there will be no weight, because the weight is acting downward na. In case of the horizontal engine there will be no WR. आता मला सांगा तुम्हाला पिस्टन एफर्ट FP हॉरिझॉन्टल आणि वर्टिकलला कसं कॅल्क्युलेट करायचं आणि साइन कन्व्हेन्शन कसे घ्यायचे हे समजले असतील तर मला सांगा, पुढच्या 5-10 मिनिटात आपलं लेक्चर संपेल. टेल मी, हॅव यू अंडरस्टँड द पिस्टन एफर्ट? व्हॉट इज पिस्टन एफर्ट? व्हॉट इज FL? फॉर वर्टिकल इंजिन व्हॉट इज हॅपनिंग? फॉर हॉरिझॉन्टल इंजिन व्हॉट इज हॅपनिंग? प्लीज मेसेज मी, हॅव यू अंडरस्टँड दिस बोथ द फॉर्म्युला? Can anybody tell me when you will take this plus FI and when you will take this minus FI? Yes, when you will take plus FI and when you will take minus FI? Yes, anyone? Hello? प्लस FI कधी घेणार आणि मायनस FI कधी घेणार FL मध्ये? हॅलो?
रिटार्डेशनला प्लस FL
आणि एक्सेलेरेशनला मायनस.
मायनस.
ओके, आणि WR प्लस आणि मायनस कधी घेणार आणि कुठल्या केस मध्ये घेणार? वर्टिकल का हॉरिझॉन्टल?
वर्टिकल.
ओके, हॉरिझॉन्टलला WR किती येणार? व्हॉट विल बी WR फॉर हॉरिझॉन्टल?
0.
येस. सो WR प्लस कधी येणार? डाउनवर्ड स्ट्रोक, आणि मायनस अपवर्ड स्ट्रोकला.
अपवर्ड स्ट्रोक.
ओके, चलो. आता नेक्स्ट, फोर्सेस ऍक्टिंग ऑन द कनेक्टिंग रॉड. आता दिस इज व्हेरी सिंपल. ओके, नाउ फर्स्ट ऑफ ऑल यू हॅव टू लुक, विल मूव ऑन टू दिस डायग्राम. ओके, सो ही जी डायग्राम आहे ना आपली मेन. ओके, so this diagram. Now in this diagram, if you want to calculate FQ, okay, I will show here only. How will you calculate? Now what is FQ first of all? FQ is nothing but a force acting on the connecting rod. So to calculate this FQ, okay, see how I am using. I am using cos phi. So this cos phi is equal to FP upon FQ, right? From this geometry of the figure, this cos phi will be FQ upon cos phi. Okay, if I take this angle, right angle triangle, and let us say if this is the FN, this will be also FN, na? So this cos phi is equal to adjacent side upon hypotenuse, that is FQ, right? So what is cos phi? FP upon FQ. Okay, clear? If I take this right angle triangle here, okay, consider that right angle triangle here. So I am getting cos phi, sorry, Fq is equal to Fp upon cos phi, right? So how can you calculate Fq? By using the sign convention. Similarly, Fn. Similarly, how will you calculate Fn? Can anybody use a sine convention? Sin phi is equal to Fn. This is a right angle triangle considered. So Fn upon Fq. Okay, that is the opposite side upon hypotenuse, right? So from sin phi and from cos phi, what I am getting? What I am getting? Anybody? What I am getting? FQ and Fn. Okay, ठीक है. तो मला FQ मिळाला, मला Fn मिळाला. आता राहिला प्रश्न FT आणि FB. आता FT आणि FB साठी how will you find out FB and FT? Okay, how will you find out this FB and FT? Yes, can anybody use this angle theta phi? Okay, so from this I will get Ft is equal to C. I am getting Ft upon Fq. Ft upon Fq is equal to I am getting sin theta plus phi, right? From this figure, sin theta plus phi is equal to Ft upon Fq, right? Similarly, for Fb, one more formula I am getting cos theta plus phi plus theta plus phi. What I am getting? Cos theta plus phi I am getting Fb upon Fq. So similarly, so for consider this phi, find Fq and Fn. Consider this theta plus phi. What you are getting? You are getting Fb and Ft. Okay. So by using this and geometry, I am finding Ft and Fb. Is it clear? Is it clear, guys? Okay. So now I will move on to the next part. So this is how I find out. See. Okay, so now in the figure I have shown you how to use the geometry. So directly use here. Okay, so cos phi is equal to Fp upon Fq. So Fq is nothing but a force acting on the connecting rod. So Fp upon cos phi. Okay, this is equal to Fp, right? And here cos phi is nothing but a square root of 1 minus sin square theta square upon n square, where n is nothing but a L upon R. That is obligative ratio. Okay, so this is nothing but the geometric formulas what I am using to calculate this. And next, Fn, thrust on the sides of the cylinder walls or normal reaction of Fn. So sin phi is equal to Fn upon Fq. So Fn is nothing but Fq sin phi. But what is Fq? Fq is equal to Fp upon cos phi. So put here sin phi upon cos phi, we are getting tan phi. So Fn is equal to Fp into tan phi. Okay, so in this way I got this formula. Fn is equal to Fp into tan phi. Okay, and Fq is equal to Fp upon cos phi. Is it clear? Okay, and next, now cramping effort and the thrust on the cramping. Now what is Fq? Fq is nothing but a force acting on the connecting rod. It is resolved into the two components. I have already explained this. What are the two components? Ft. Ft is nothing but a tangential force perpendicular to the crank. What it produces? Cramping effort means what? Torque. What is Fb? Radial force which is acting along the crank. What it produces? Thrust on the crankshaft bearings. Okay. So this Ft is equal to, I said earlier, in the if you look into the figure properly, sin theta plus phi is nothing but opposite side upon hypotenuse. So Ft upon Fq, right? So from this I am getting Ft is equal to Fq sin theta plus phi. But what is Fq? Fp upon cos phi. Okay. So in this way, from this figure I am getting the formula for the Ft. Okay. So see here, I have just calculated first Fp and rest I am calculating using a force diagram. So it is very, very important that you should be able to draw this force diagram. Okay, next. What is Fb? Now we know that from the figure cos theta plus phi is equal to adjacent side, that is Fb upon Fq. Okay, so from this I am getting Fb. Okay, clear? So Fb is equal to, and now cramping effort. What is this cramping effort? This cramping effort, हा cramping effort पुन्हा produce झाल्यापर्यंत मला सांगा. A cramping effort, your turning movement. Cramping effort means what? Torque. लक्षात घ्या. Effort means torque. एक छोटा गेअर घ्या, एक मोठा गेअर घ्या. छोटा गेअरला जेव्हा मोठा गेअरला आपण फिरवतोय, when the smaller gear is rotating the larger gear, that it requires a larger effort. When the larger gear is rotating a smaller gear, it requires a smaller effort. So torque is nothing but a turning effort. Okay. So cramping effort. Cramping effort means what? The torque required to turn the crankshaft. That is nothing but a cramping effort. So cramping effort is nothing but a torque acting on the crankshaft, and it is given by T is equal to Ft into R. हा जो Ft म्हणजे काय? Ft is nothing but a tangential force. Ft is nothing but a tangential force acting along the acting perpendicular to the crank. So this Ft multiplied by R. R means what? Cranking radius. You will get a T, that is a crank effort or the torque. Is it clear? Now let me derive the formula for this. So easy. Now we know that what is T? First of all, T, Ft into R. But what is Ft? What is Ft? Now we know that T is equal to Ft into R. So Ft is nothing but Ft cos phi into sin theta plus phi into R. Okay. So sin theta plus phi. Now we know that sin A plus B, sin A plus B, sin A into sin B, sin A into cos B plus cos A into sin B, right? So I am using this formula. So sin theta plus phi, sin theta into cos phi plus cos A into sin phi, and from this I am getting this. Okay. Now if you look into the figure, we know that L sin phi is equal to R sin theta. Means what? It basically like sin theta upon sin phi is equal to L upon R. Okay, you remember this. This is nothing but a geometric progression. So sin theta upon sin phi is equal to L upon R. Okay, so basically what I am getting, so sin phi is equal to R upon L into sin theta. Now what is N? N is nothing but an obligative ratio L upon R. So I am getting sin theta upon L. Okay, so this is a small derivation I am deriving. What is cos phi? Cos phi is nothing but a straight of 1 minus sin square phi, which is equal to 1 minus sin square theta upon n square. This is all mathematics, huh? Guys, this is all mathematics what we have studied. Is equal to 1 upon n square minus sin square theta, and tan phi is equal to sin phi upon cos phi. So finally, sin phi is equal to sin theta upon n into cos phi is equal to n upon n square minus sin square theta. So put cos phi, put sin phi, you are getting this tan phi. Okay. So what is tan phi? So finally, what I am doing, I am trying to derive this tan phi sin theta upon n square minus sin square theta. You don't have to remember this derivation. You have to remember the final formula. Now what is t? T is equal to t. What is this t? T is equal to Fp into sin theta plus cos theta into tan phi. Put everything over here. Whatever you have derived, put everything over here. What you will get? P is equal to Fp into R sin theta plus cos theta sin theta and so and so. And finally, now since sin square theta is very small as compared to the n square, you can neglect it and you are getting final formula. Fpr is equal to sin theta plus sin 2 theta upon 2n. So neglect this term. So this is the final formula which you have to remember. So how to calculate T? So you can calculate the T. What is T? Torque acting on the crankshaft. T is nothing but a torque acting on the crankshaft is equal to Fp into R. What is Fp? Piston effort multiplied by R, cranking radius, multiplied by sin theta plus sin 2 theta upon 10. N is what? Obligative ratio, L upon R. And what is theta? Angle turned by the crank, or theta is nothing but a crank angle. So what I have done, guys, I have taken a case study of a slider tank mechanism, ICG component, and I have derived a formula for the forces acting on the this one. Okay. Now tell me, have you understand this or not? Have you understand this? Okay. So see how many formula I have derived. I have derived a formula for the T. Okay. Then I have derived a formula for the FB. What is FB? FB is equal to Fp upon cos phi into cos theta plus phi. So guys, you have to remember this all the formula. Otherwise, you have to do the derivation in the exam. And what is Fp? Ft is equal to Fq sin theta plus phi. And what is Fq? Fp upon cos phi. Remember this. Then what is Fq? Fq is equal to Fp upon cos phi. What is Fn? Fp upon tan phi. Okay. And then finally, what is Fp? For horizontal engine, FL plus minus Fi plus minus WR, and for vertical engine, this is for vertical. For horizontal engine, FL minus plus Fi minus RF. So this will become 0. Okay. So tomorrow in the next lecture we will solve the problems on this. And finally, I've got this diagram. So in this force diagram, so this is nothing but a force diagram for a slider tank mechanism. So Fp is what? Once again revise. Fp is what? Piston effort. Fn is what? Side thrust acting on the cylinder wall. Weight of the reciprocating parts. Okay. Fp is nothing but a force acting on the connecting rod. Ft is nothing but a tangential force perpendicular to this crank OC. Ft is perpendicular to OC, right? Fb is nothing but a radial force acting along the crank. This Fb produces the thrust on the crankshaft bearing. Ft produces the what they produces a what they produces FT produces a torque. Now tell me, is there any doubt in this? Is there any doubt? Anybody? तुम्हाला यातला कुठला पॉइंट कळला नाहीये असं काय? Anybody? Hello? Yes, anybody, any point if you don't have understand. तुम्हाला हे कळलंय का? हा sin theta plus phi हा मी कसा काढला? हा sin theta plus phi आणि cos theta plus phi हे आता हे फायचं अनालिसिस कसं कळलं तुम्हाला असेल ना. हे राईट अँगल ट्रायंगल मी घेतला म्हणजे FN आणि FQ मी कॅल्क्युलेट केला आणि FT आणि FB कॅल्क्युलेट करण्यासाठी मी हा अँगल कॅल्क्युलेट केला थीटा प्लस फाय. तर हा कसा केलाय कळलंय तुम्हाला तर सांगायला पाहिजे. अपोजिट साइड आपण येस प्लीज राजेंद्र अँड ऑल एनीबडी हॅव यू अंडरस्टँड दिस और नॉट? आय विल एक्सप्लेन इफ यू
Yes, sir.
कसं आलाय कळलं ना तुम्हाला कसं केलं. सी याच्यासाठी मी काय केलं जर समजलं नसेल ज्यांना तर इथून मी फक्त एक लाईन ड्रॉ करायची. इथून कशी लाईन ड्रॉ करा. लाईन ड्रॉ केल्यानंतर हा अँगल कुठला होणार मला सांगा. हा अँगल राईट अँगल ट्रायंगल झालं ना. हा बरोबर ना. एक तर तुम्ही हा घ्या हा राईट अँगल ट्रायंगल झाला बरोबर ना. म्हणजे हा काय झाला FT झाला बरोबर ना. किंवा हा FT कन्सिडर करा आणि हा FB कन्सिडर करा. ओके सो दिस कॅन बी ऑल्सो FT अँड दिस कॅन बी ऑल्सो FT. सो बेसिकली तर हा तुमचा थीटा प्लस फाय असेल ना आणि हा जर तुमचा FT असेल आणि हा तुमचा काय असेल FQ असेल बरोबर ना. सो ह्याच्यावर तुम्हाला साइन थीटा प्लस फाय किती मिळणार म्हणजे असा ट्रायंगल झाला बघा. हा असा ट्रायंगल झाला बघा. हा किती झाला हा असा असेल. हा झाला थीटा प्लस फाय एम आय करेक्ट ऑर नॉट. आणि हा झाला FQ आणि हा झाला FT बरोबर. आणि ह्याच्यावरनं मी ते कॅल्क्युलेट केलं. इथे पण तसंच हा ट्रायंगल तयार झाला आणि ह्याच्यावरनं मला ते मिळाले बाकीचे म्हणजे काय मिळाले मला साइन थीटा प्लस फाय इज इक्वल टू अपोजिट साइड. अपोजिट साइड काय म्हणतो आपण FT अपोजिट साइड ना बरोबर. FT आपण FQ मला मिळाला ह्याच्यावरनं मला मिळालं. हा ट्रायंगल कसा आला कळलं ना तुम्हाला. आणि सिमिलरली कॉस जर थीटा प्लस फाय मी घेतला कॉस थीटा प्लस जर फाय मी घेतला तर तो किती येणार तुम्ही सांगू शकता. कॉस थीटा प्लस फाय मी घेतला तर किती येणार. हा FB लेट अस से दिस इज नथिंग बट FB म्हणजे हा FB ऍडजस्टंट साइड आपण हायपोटेन्यूज FQ पण FQ. ओके सो इथनं एक जर मी लाईन ड्रॉ केली तर हा FT झाला ना रे आणि हा FQ झाला आणि हा FB झाला. क्लिअर क्लिअर झालेत काही अँगल